Day mathematics. Whoop whoop. How's everybody doing? Good? Ready to rock and roll? Rock and roll. Yes. Let me move this out of the way. Alright, so really quick, the warm-up that, the agenda reads as follows. Warm-up number 5. We're still going to be on equations and inequalities today. We finish up. And we're going to have 12 problems for home plate. Only. Get it? Only? Yeah. And it's basically a play sheet. I'll show you that in a little bit. And before I continue, let me bring myself in here. Let's see. There I am. Hopefully this comes out. Alright. So, check this out, guys. I have a big shout out. Look at my shirt. I have the Tigers robotic team. Shout out to Miss Lopez and her Mesa team. Let's go. Keep up the good work. Just wanted to show my gear. Thank you, guys. Alright. So, warm-up for today, number 5. Warm-up number 5 should be on the screen. There it is. And it reads as follows. It reads, number 1, simplify. -1 plus 2x plus -3 plus y plus -4x minus 3y plus 5. For numbers 2 and 3, it says solve. Number 2 reads 3 open parentheses x plus 1 close parentheses minus x equals 2 open parentheses x minus 3 close parentheses minus open parentheses x plus 4 close parentheses. And number 3 reads -1/3 x plus 2/4 greater than 4 over 24. Copy and work on those, please. I'll give you guys about 5 minutes. And those of you that are watching on video, you may pause the video at this time and work on those. Alright, so now that you've worked on it, here are the solutions for this. Is number 1, simplified right there. This is number 2, x equals -13, and number 3, x less than 1. Just remember here, don't forget to distribute the negative with a coefficient of 1 into each term when you simplify. And here, don't forget to multiply times the common denominator, and since at the end we divide by a negative, what happens to the inequality symbol when we divide and multiply by a negative? It flips. Okay. Alright. So, copy this code, please, everyone. Now, the reason I'm giving you this code is for your asynchronous assignment. So your home play, guys, is a play sheet, or some of you know them as worksheets. So your play sheet is going to have 12 problems in there, and but I included that in a Nearpod presentation as a PDF reader. What does that mean? That you can tap on it and you can actually zoom into each of the problems, or you can download the PDF to your device, or like that you can use that or manipulate it any way you want. But that's going to be for your home play. So the Nearpod code for the asynchronous session is WYIHM. And remember, when you sign in first with the number of the period that you're with me, and then your first name and your last name. Okay? Alright, let's move on. Get your home play from last time out, and we're going to turn that in. Let me pause this really quick. So your home play, like I said, it's going to be only 12 problems, only. And you wrote the code down earlier. Once again, it's going to be in the Nearpod presentation. Make sure you go there to get that. If not, it's also here in the video. You can pause it and zoom in if you can, but if you can't, then like I said, you need to go to the Nearpod presentation, asynchronous presentation, so you can get the worksheet, or the play sheet, my bad. Alright, let's move on. So, quick recap. Let's see. Let's look up to the screen. Last time we covered equations and inequalities, and I said equations and inequalities come from scales. We said that if the scale is even, it's an equation. If it's not even, it's an inequality. One side is greater than the other. Is that correct? Yeah, Mr. Q. And then we did something like this, something like this, something like this, and so on and so forth. Okay. So our objective for today, I can solve one variable equations and inequalities. Copy that down at the bottom left of your notes. I can solve one variable equations and inequalities. And if I asked you what is the main idea or the concept for today, you would say one variable equations and inequalities. That is correct. And what are we doing with that? We're solving. We're still solving. Okay? All right? And then we did a Fourier model. So I want you to make another one. Write one variable equations and inequalities in there. And you're going to fill it in by yourself without looking at your notes. You're like, oh, snap, Mr. Q. I know, right? Yeah, I got you. I got you. So think about it. What are one variable equations and inequalities? We covered that last time. Hopefully you remember. Okay? So I'll have you do that on your own once we get off from this presentation. But it looks something like this. You needed a definition, examples, non-examples, and some hashtags. So make sure you fill that in. If you forget, then go to your notes so you can remember. And the reason I'm having you do it again, so like that you remember the definition and what it looks like of the main concept. Steps. I gave you guys 4 steps. Simplify, isolate, plot, and check. You don't need to copy those. That's just a refresher. Okay? So today we're going to be using all these steps. So everybody look up, go like this. Bear with me. I love it. Alright, let's move on. Alright, here we go. Writing utensils down, look up to the screen. Please, pretty please, look up to the screen. Writing utensils down. So, we're going to recap or reintroduce something that you covered in the past known as compound inequalities. Now maybe you haven't seen the presentation like mine because I put it together in like this. It has a purpose so you can see where compound inequalities come from. Do not copy what's on the screen. I'm just going to show you where they come from. So writing utensils down, look up to the screen. Here it goes. If I was to give you this inequality, -5 less than x plus 1, and I asked you to solve it, what do we need to leave by itself? The x. So what do I need to do? I need to subtract 1 to each side. Is that correct? That leaves me with -6 less than x. So far so good? Yeah. To graph this, I draw my number line. Here's 0, and -6 is over there. And by looking at the inequality sign, it's an open point. That means we do not include -6 in the solution. If I was to test a point, I'll test 0 here. Is -6 less than 0? Yes, that means I'm going to shade towards 0 because all these are solutions to the inequality. Okay, once again, you're just paying attention. And the reason I say writing utensils down, eyes on the screen, because our brain, guys, sometimes cannot multitask. So if I'm trying to convey a concept and you're writing down something, your brain is concentrated on writing things and not learning things. So please, writing utensils down, focus on the screen. If I was to give you a second inequality, such as x plus 1 less than 2, to leave x by itself, what do? -1 minus 1, this cancels, 2 minus 1 is 1, so we will end up with x less than 1. So far so good? Yes. To graph that, I draw my number line. Here's 0, and then I got 1. Does it include 1? No, it doesn't have an equal sign, so it's an open point. There it is. So I'm going to test 0. I'll substitute that in here. Is 0 less than 1? Yes, that means I'm going to shade now towards the left. There it is. Do you agree with that so far? Yeah, right? That's what we did the other day, and it works. Today, we're going to work on something called compound inequalities. Look up to the screen. The word compound means combined. Let me show you what a compound inequality looks like and where it comes from. Look up. Look at this. I'm going to bring that together this way. And look at this one. I'm going to bring it together this way. What did I just do? I combined two inequalities together. And that, look up to the screen, way at the top, look at what this looks like. That is a compound inequality. So what can we conclude? That a compound inequality is made up of how many inequalities? Two. But they intersect. Is that pretty clear, yeah? You guys remember? Kind of, sort of, yeah? Is it coming back for some of you? Good. All right. Copy this one, example 1. Turn your paper over because you need it to leave your Ferrier model, space for your Ferrier model. Example 1 reads, solve, graph, check, and write the solution set of -5 less than x plus 1 less than 2. Just copy that. I'm going to go over the process for that one completely, and I'll give you a second one for you to practice. Copy that, please. Go. All right. Writing utensils down, look up to the screen. Please, pretty please, I'm going to go through the process, and then I'll have you copy next, and then so on and so forth. So right now, writing utensils down, look up to the screen. Here it goes. So, if I was to ask you to solve this compound inequality, but now that we know what they are what? 2 inequalities in 1. Is that correct? So the process is the same as the one we did. Simplify, isolate, plot, and check. So I would do this. Line down the inequality sign, but now we have 2 of them. And right now you're just paying attention. You'll copy at the end. Question. Can I simplify the left side anymore? No. How about the center? No. How about the right side? No. It's all simplified. Okay. What's the next step? Isolate. We need to leave x by itself. What do I need to do here to leave x by itself? -1. But we do that to all sides. Cancel. We're left with -6 less than x less than 1. And we're done solving. Copy that. Alright guys, once again, if you haven't gotten your materials, please get them as soon as you can, because we're going to start getting into multi-step problems pretty soon, if we haven't already. And we're going to need a different color so you can see the different things that I'm going to do with the different colors. So make sure, if you have your colored pens, have those handy. Alright, writing utensils down, look up to the screen. So, what did we just do? We just solved. We're done with solving. What's next? We need to graph. So let me move this up a bit. Alright, so here goes to graph. Look up to the screen, please. So I'm going to set my 0 right there. And I'm going to use red to graph the first half of this compound inequality. Writing utensils down, look up to the screen. So I'm going to graph this half. Okay, so I'm at -6. Does it include -6? No, it doesn't have an equal sign, so it's an open point. Okay, so Mr. Q, how do I know which direction to shade it? Well, we already know how to test it, right? I'm going to test 0. So here instead of x, I'm going to substitute 0. And let me read it. Is -6 less than 0? Yes, that's true. So that means I'm going to shade towards 0 because it did work. Alright. I'm going to switch colors. Now I'm going to go with green, and I'm going to graph the second half of this compound. And you're just paying attention. So, what number do I... Oh, my 1 goes right there. Does it include 1? No, it doesn't have an equal sign. It's an open point. And I'm going to test 0 again. So here instead of x, I'm going to write 0 less than 1. Okay. Is 0 less than 1? Yeah, that is true. So that means I'm going to shade towards 0, but I'm going to keep going. There it is. So what do we notice? That they intersect here. When 2 graphs intersect like this, this is what we know as and compound inequalities. Copy that, please. Alright, so let's see where we're at. Did we solve? Yes. Did we graph? Yes. What's next? Check. Okay. So look what I'm going to do. Let me make some space over here on this side. Alright, so you're going to write check. To check, we need to use the original inequality. So I have -5 less than x plus 1 less than 2. Okay, so which point do I check, Mr. Q? Any point where both shadings intersect. So what point can I use from in here? I can use any point, is that correct? So just yell, which number do you want me to use from the intersecting section?
-3.
-3. Does everybody agree that's in between? Yes. So I'm going to use -3. So in here, instead of x, I'm going to write -3, and I bring everything else down. -5 less than -3 plus 1 less than 2. Sorry. Then we get -5 less than, what is -3 plus 1? -2 less than 2. All right. Let's read the entire statement from left to right. Let's see if it worked. Is -5 less than -2? Yes. Is -2 less than 2? Yes, it did work. So we put true and check. It did work. So let me ask you a question, guys. Look up to the screen. What would happen if I chose a point from over here, or just a point from over here? Would that work for the entire statement? No, it has to be from in between. That's why it's this or that, or what we call this and that. Yes, question? No? Okay. Are we done? No, we got solving, graphing, checking. Now we need the solution set. Look up to the screen. This is how you write your solution set. Look up. We start with a bracket. That means the set of. When we start with a bracket, it means what? The set of. When we start with a bracket, it means what? The set of. What does this mean? The set of. What does it mean? The set of. What variable are we working on? X. So the set of all x's, and then a bar down, such that. You always start your solution set like that. The set of all x's such that. And what goes after that? Our solution. Look up. Our solution was right here. Right here. Do you guys see it? So we write that here. -6 less than x less than 1. Close the bracket, and that is our solution set. Is it coming back? Yes? Yes, Mr. Q. All right. Show me with your fingers how comfortable you are with E so far. Is it coming back? 1 being the lowest, 5 being the highest. Where are we at? Got some 5 4s, 5 4s, 5 4s, 5 4s, 3s, 5 4s, 5 4s, 3. Okay. All right. So that means you need to practice it, right? Example 1Q. See how you do with this one. 12 less than or equal to Q minus 8 less than or equal to 15. Copy that, and I want you to solve, graph, check, and write your solution set. Copy that and go. I'll give you some time. Those of you that are watching on YouTube, pause the video. Alright, just to save some time, let's see. I'm going to go over the entire process, see how you did. Laying down the inequality symbols, we need to leave Q by itself, so we add 8, add 8, add 8. So we're left with 20 less than or equal to Q less than or equal to 23. Did we solve? Yes, this is our solution. Hands if you got that. Okay, good. Next, let's graph. To graph, let me graph it down here. 0. I'm going to graph 21st in red, the first half, and I'm going to test 0. Is 20 less than or equal to 0? No, Mr. Q, that's false. So instead of going towards 0, I'm going to go the opposite direction. However, is it a close point? Yes, it's a close point because there's an equal sign right there, and it's going the opposite direction. Okay, let me switch to green. Now I need to graph this part. I need to test a point. I'm going to test with 0 again. Is 0 less than or equal to 23? Yes, that is true. 0 is less than 23. So 23 is right there, solid point, and I'm going to go towards 0 because it did work. And what kind of compound inequality is this? An and. Okay, hands, have you got that? Okay. Next, we need to check. What number did you use to check for this one, Alberto?
21, I'm sorry.
What number?
21.
21. Yes, so we substitute that into here, 21. So we get 12 less than or equal to 21 minus 8 less than or equal to 15. So that gives me 12 less than or equal to 13 less than or equal to 15. Let's read it from left to right. Is 12 less than or equal to 13? Yes. Is 13 less than or equal to 15? Yes, that's true, and that's how you check. Any number in between there, yes. And lastly, solution set of Q such that, and what was our solution? 20 less than or equal to Q less than or equal to 23. Hands if you got that by yourself. Let's go. Yeah, piece of cake. Alright, one more. See how you do with this one by yourself. Example 2. 8 less than 3x minus 1 less than or equal to 11. Go ahead and do that one by yourself. Once again, example 2. We're going to solve, graph, check, and write the solution set of 8 less than 3x minus 1 less than or equal to 11. Copy that and go. You got 1 minute. Alright, should be just about done. Here goes the process, just to make sure that you got it. Line down the inequality symbols. And let me switch. Alright, I need to leave x by itself, so you should have added 1 to all sides. Then you got 9 less than or less than 3x less than or equal to 12. And then we still need to leave x by itself, so you divide it by 3, all sides. So we end up with 3 less than x less than or equal to 4 as our solution. Hands if you got that. Let's go! Alright, next let's graph this. I got 0. Then let me move this up. And I'm going to graph with red the first part, which is this. So I got 3 right here. Open point. Test 0 is 3 less than 0. No, that's false. So I'm going to shade that way. Next, I'm going to do the second half in green, which is 4. I'm going to test 0. Is 0 less than or equal to 4? Yes, that's true, Mr. Q. So it's a solid point, and it's going towards 0. And this is an and. Alright. Check. We got 8 less than 3x minus 1 less than or equal to 11. What point is in between? Any decimal point. So I'm just going to do 8 less than 3 times minus 1 less than or equal to 11. And I'm going to choose the point halfway, which is 3.5. So that gives me 8 less than 10.5 minus 1 less than or equal to 11. 8 less than 9.5 less than or equal to 11. Let me read it. Is 8 less than 9.5? Yes. Is 9.5 less than or equal to 11? Yes, it's true. So that's a check. So my solution set of x such that, and what was my solution? It's right there. 3 less than x less than or equal to 4. Let's go. Alright. Show me your fingers how come you are with these. 1 being the lowest, 5 being the highest. 5s, 5 4s, 5 4s, 5 5 5s, 4s. Okay. Let's move on. This is too easy. Too easy. Not too easy, it's too easy. Copy this one. Example 3. And it reads 8 plus t greater than or equal to 7, or 8 plus t less than 2. And we're going to do this one together, because this is a very simple inequality, and you'll see it right now when we do this. So we have 8 plus t greater than 7, or 8 plus t less than 2. So here we go. Let's work on this one first. I'm going to do that in red. To leave t by itself, I subtract 8, I end up with t greater than or equal to -1. Bring down the word or. Some of you are like, why is that, Mr. Q? I'll show you right now. Let's do this one. I'm doing that in green. We need to leave t by itself, so what do? -8 minus 8. T is less than -6. Alright, so if we were to graph that, here we go. I'm going to get my number line going. Here's 0. I'm going to start with -1. Does it include it? Yes. I'm going to test 0. So is 0 greater than or equal to -1? Yes, that's true. So I'm going to shade towards 0. Okay. Next one, -6. Does it include the point? No, it's an open point. And let's see, I'm going to test 0. Is 0 less than -6? No, that's false. 0 didn't work, so I'm not going to shade towards 0. I'm going to shade the opposite direction. What do you guys notice? Do those graphing or do those graphs intersect? No, that's why these are known as OR. The solution can only be one set or the other set. It doesn't work for both. And let me show you. Look up to the screen. We already checked it. Look up. Look at this. On this side we tested 0. Did it work? Yes. Did it work over here? No. That's why it's known as OR. It either works for one or the other, not both. When it works for both, it's a what? An AND. This one is an OR. Does that make sense? For sure. See what it is there? For sure? No? Alright. Solution set. Solution set of t such that, and then we just write our last inequalities before we graph, which is that. So we write t greater than or equal to -1 or t less than -6. Fairly simple. You're like, yeah, it seems easier than the other one. So what can we conclude? Let's see. The previous one we did what? These kind, and when they intersect, what kind of inequalities are they? And when they don't intersect, what kind of inequalities are they? OR. Okay, if that's true, look up. Look at this graph. Look up. Tell your neighbor right there, whoever's there, or your cat, your dog, your pillow, tell them what kind of inequality this is. What would you say, Roman? What kind of inequality is this? It's a comp. What is it? An AND. That is correct. So, if it is an AND, we need to write a compound inequality. Let me show you how to do that. Here it goes. I'm going to write AND. Check this out. This is how you write it. I start with one end. I go to the next, and what number is here? This is a 5, so I write 5. I need a variable for in between. Doesn't matter which variable you use. I'm going to use the letter Q. Whenever you have an AND, the arrows are always to the left. And then just check if this is a solid point, you would put an equal sign, but since both of them are open, I won't. And then we just write our solution set. Solution set of Q such that, and you close it. Copy that, please. So, here goes the process one more time. If they give you a graph that looks like this, that it looks like it only has shading in between, then it's an AND. What do you write? The numbers on the extremes, those are known as dividing points, so we write -2. This one was 5. Pick a variable for in between, and arrows to the left. If these are solid points, you put an equal sign, but since it doesn't, it's like that. Then you just write your solution set of that variable such that, and you close it. That's how you write your compound inequality for AND from a graph. Look at this one. Example 6. Everyone, what kind of compound inequality is that? OR. That is correct. So, how do we write our compound inequality for this one, Mr. Q? Well, let me show you. Let me show you. Let me show you. Come on, computer. I'm going to replace you. Huh, Juan? We're going to replace that? My goodness. Alright, here we go. I'm going to start with blue. So I'm going to go with this side first. Look up. What's my dividing point? -3. And this shading represents a variable. I'm going to use x. So think about it. All these numbers are what compared to -3? All these numbers are less than -3. All these. Does it include the point? Yeah, because it's a solid point. I put an equal sign. So I'm done with that side. And then what do we write for the empty space? Or. Let's go to the other side. We got 2. All this represents x. So question. 2 compared to all these numbers. Because we read it from left to right. 2 is what to all these numbers? Less than. Do we include the 2? Yes. Alright. And then we just write our solution set of x such that, and you close it. Copy that. Bam! Let's go! Man, this is too easy. Not too easy, it's too easy. Alright? Alright, show me your famous how comfortable you are with compound inequalities. 1 being the lowest, 5 being the highest so far. Where are we at? 5 4s, 5 5 5s, 4 5s. Okay. So all we need is to practice. Once again, 3s, 4s, 3.5s. Once again, your home play for tonight is play sheet 3.6. Let me show you that. Again, home. Your asynchronous code, once again, WYIHM. You're going to need that to get your home plate from Nearpod. And your home plate is going to look like this. It's going to be play sheet 3.6. There's only 12 problems. There's 2 word problems at the bottom, and I want to see how you graph those, see if you kind of like convey what we just did on the practice. But the rest of them should be just about exactly what we did in class. Okay? Alright guys, that's going to be our session for today. Alright? So next week, remember, make sure you have all your materials, make sure you have your textbooks, and just be ready because we're going to start already with our Algebra 2. Let's go! Everybody with me? Yeah? Alright guys, well, good seeing you again. Keep up the good work, and do your home play. See you guys next week. Alright? Peace.